In this video, we're going to learn how to prove a quadrilateral is a parallelogram. So there are several different ways you can go about doing this. The most common is to use the definition of a parallelogram, and that's to prove that both pairs of opposite sides are parallel. So this is the most common, and when you're doing like a coordinate proof, since you have control of really how you're going to go about it, this is definitely the most common way. You do have some other options though. You could prove that both pairs of opposite sides are congruent. You could prove, so this is actually number 3, 4, and then 5. You could prove that the same pair of opposite sides is both parallel and congruent. Be careful with this one though. You have to make sure that you're talking about the same pair being both parallel and congruent, because otherwise we could get into the situation where we're dealing with an isosceles trapezoid. And then for 4 and 5, these are less common, but these are definitely things that you can think about when we get into our Euclidean style proofs. So a quadrilateral with both pairs of opposite angles congruent means it's going to be a parallelogram. You also have the diagonals bisecting each other. So that's often a very quick and easy way, even in the coordinate plane, is to prove that the diagonals bisect each other. So basically show that the midpoints are the same of the two diagonals. That would mean that they bisect each other or cut each other into two equal parts. Quick and easy. Not as common, but it's quick and easy. So like I said, the most common is this first one, and this is pretty much what I'll use for coordinate proofs, but you can use distance formula and prove that opposite sides are congruent, or you could use the midpoints to get the diagonals bisect each other, but I'm going to go ahead and use the opposite sides are parallel using my slope formula. So this is going to be slope versus this one would be distance, and then the last one here would be midpoints. And this is when we're talking about coordinate proofs. So for the first example here, we have a coordinate proof. I'm going to go ahead and graph those points to start. So I have 3, 4. So 3, 4, 1, 2, 3, 4. Making sure that we're labeling our points is so important when we're on the coordinate plane, so we know which points go together. So negative 4, 1, 2, 3, oops, 1, 2, 3, 4, down 2, and then 0, negative 1. So when you're looking at this, make sure that your drawing actually looks like a parallelogram, right? That's a good hint that you've drawn it correctly. So just be aware of that. And what I'm going to do is I'm going to show that opposite sides are parallel. Both pairs of opposite sides are parallel. So that's the method I'm going to choose. And like I said, you can pick any of the above methods. The only one that wouldn't work on a graph would be showing opposite angles are congruent, because there's not a formula for you to be able to find the angle measures on a graph. So that's definitely a Euclidean method. So we're going to show both pairs of opposite sides parallel. That's how I'm going to do this. So you could count rise over run on your graph. I'm just going to use the slope formula just to practice that. So my slope formula is going to be the change in y's over the change in x, or y2 minus y1 over x2 minus x1. Let me rewrite that. Keep in mind with these, when you're doing your coordinate proofs, that you need to write your formula at least once on the page, and then you need to show all of your substitutions. You want to make sure too that you're being careful about your labeling. So for example, the first slope I'm going to find is the slope of AB. So notice that I put the little m with the subscript AB. And then I'm going to go ahead and pull for my coordinates up top. So I have 3 minus 4, and then negative 1 minus 3. So I'm getting negative 1 over negative 4, which reduces down to 1/4. I could do a quick check over here. That's up 1 over 1, 2, 3, 4. So that looks good. I'm going to go right to side CD because I want to catch any mistakes right away if I were to make any. I would want to check that these slopes are the same before I move on, just in case I make a mistake. So then I'm going to move to CD. So CD, I'm going to do my y's, so it's going to be negative 1 minus negative 2. Watch that double negative there. And then 0 minus negative 4, again, another negative. So then this is going to become addition, so I'm going to have 1 over positive 4, so that checks. So this tells me that AB is parallel to CD because the slopes are equal. And then I'm going to go ahead and do the same thing for the other two sides. So I'm going to mark these two since I know that they're parallel. So now I'm going to find the slope of BC. So BC, I have my y's, so -2 minus 3. Then the x's, -4 minus -1. So I end up with -5 on top, and this is going to be -3 on the bottom, so 5/3, positive 5/3. And again, you could check that. So it's up 1, 2, 3, 4, 5 over 1, 2, 3. So that looks good. And then I'm going to go ahead with AD. So it's going to be -1 minus 4 on top, and then 0 minus 3 on the bottom. So -5 over -3. Negative divided by negative becomes positive. So checks out. So now I can say BC is parallel to AD because, again, equal slopes. And then to finalize this, we just need to write a conclusion. So your conclusion should always start with what you're trying to prove. So I'm going to start with that. So for my conclusion, I'll write it right over here. I can say that quad ABCD is a parallelogram. Remember, you can use these abbreviations. And then because, make sure that your explanation matches your work. So meaning I shouldn't say because both pairs of opposite sides are congruent, even though that's a true statement, I didn't prove that. So we have to make sure that you use what you've proven. So you've proven that the opposite sides are parallel. So quad ABCD is a parallelogram because both pairs of opposite sides are parallel. And I'm just going to write in parentheses equal slopes because that way if you don't state it over here about the equal slopes, at least you're covering it in your conclusion. So you can kind of pick and choose. It's great to cover it in both places, but just in case, at least make sure you talk about it in your conclusion. So now what I'm going to do is let's look at a Euclidean proof. So Euclidean proof means you're not really in control of what method you can use. You might be able to use more than one of these, but a lot of times you're kind of restricted because it's all based on what's given to you. Versus a coordinate proof, you can really decide which way you want to go about it. So let's go ahead and just look at what's given to us. So we have, in this picture, we have two triangles that are congruent. So right away, I know a lot of information about those two triangles. I know all their corresponding parts have to be congruent. So I have LGS and I have HAF, so these two triangles. So those two triangles are congruent. So I'm going to write it down as my given. So triangle LGS. So we're getting into the good old flow proofs again. So we have these triangles are congruent. That's given. So now I can think about CPCTC to get any of the parts in those triangles congruent. So think about the parts that would be convenient to use. We're trying to prove that FLHS is a parallelogram. So we're trying to prove that this whole thing is a parallelogram. So right away, my attention is drawn to these two sides, LS and FH, because those are both sides in my triangles as well as sides in the parallelogram. So right away, I know that those have to be congruent because they belong to congruent triangles. So I'm going to go right off of this and say that LS is congruent to FH, and that's going to be by CPCTC. Corresponding parts of congruent triangles are congruent. And then I want to think about my methods up here. So my methods, I have right now one pair of congruent sides. So I know one pair of opposite sides are congruent. And really there's two methods that I can think about. I can think about the method where both pairs of opposite sides are congruent, or I can think about the same pair of opposite sides being both parallel and congruent. So the question becomes, which one of those can I use? And if you think about your triangles, there's no way really for me to be able to get these two sides congruent unless I can get these smaller triangles congruent first. But I can get these LS and FH parallel because when I look at this picture, I'm seeing that Z shape right here. And I'm thinking about those alternate interior angles, which happen to be angles in those congruent triangles. So I'm going to number those 1 and 2 because I don't like using 3 letters if I don't have to. And I'm going to say angle 1 is congruent to angle 2 by CPCTC. And then from there, because those angles are congruent, that means that these lines are parallel because we have congruent alternate interior angles which form parallel lines. So now I can say LS is parallel to FH. And remember that you state congruent alternate interior angles imply parallel lines. Don't forget the congruent, because if you just say alternate interior angles, those do not make parallel lines. Those just are a name or a vocab term for those angles. So now that I have the congruent alternate interior angles, that gives me that the lines are parallel. Now I can conclude it. I can finalize this. I can say that quad, I'm just going to go up top here for the ordering, FLHS. So FL, that's actually, now that I'm reading that, that's actually labeled wrong. It should be FL, this should be HS, or we should change that letter. So just make that change. Let's just change our picture. Since I use numbers, it won't affect the, actually, it will affect our whole proof. So let's do it this way. Sorry about that. Let's change this to SH. FLSH, because otherwise our whole proof, all those letters are going to get messed up. So FLSH, FLSH is a parallelogram. And notice I didn't use that symbol. I don't like using that symbol as a parallelogram symbol because I feel like that could also mean that it's a quadrilateral, unless you're assuming that's a parallelogram. So I'm just going to say FLSH is a parallelogram. My reason for that is because a quad with one pair of opposite sides, both congruent and parallel, implies a parallelogram. So basically I just took that explanation from up top and kind of just shortened it up a little bit. Notice I underlined both because they have to be both congruent and parallel in order for this to actually work. So there you have it. So go ahead, get some key ideas written down and try to check your understanding, and we will talk about those in class tomorrow.